Our next speaker is a dear colleague and friend, Dana Jalobeanu. She's with the University of Bucharest, the Department of Theoretical Philosophy, and she is also the head of the Humanities Division at ICUP, that's the research institute at the same university. I'm happy to say that Dana is also an acting president of the European Society for the History of Science, following Bewaga, another one of our speakers here in the conference. Our next talk in the Kuhn 100 conference, given by Dana, will be titled Turning Labels into Historiographical Categories, Baconianism and Newtonianism in Early Modern Europe. It is a pleasure and a privilege to be here witnessing your talk. Dana, please take it away.
Thank you, Andre. My talk tonight will be only tangentially on Kuhn, so it will reflect on more general issues. It's part of my ongoing work in progress on the subject of how do we produce historiographic categories. And I'm starting from Kuhn, and at the end I will come back to Kuhn, and I will kind of integrate Kuhn into a more general story in which I invite reflection on the procedures by which we operate in order to raise historiographic categories. So in a seminal paper, Kuhn created a historiographic categories with a long life and a long-lasting divide between Baconian sciences, and the classical or Newtonian science. And somehow the two were meant to represent two stages in the development of scientific knowledge, the enterprise of the exploration of nature versus the mature paradigmatic normal science. Essentially an enterprise of fact gathering. It was experimental, qualitative, utilitarian, and often rather vague. Or in Kuhn's own terms, when its practitioners, namely the practitioners of the Baconian sciences, performed experiments, they wished to see how nature would behave under often previously non-existing circumstances. Their typical products were the vast natural or experimental histories in which there were amassed the miscellaneous data that many of them thought prerequisite to the construction of scientific theory. According to Kuhn, Baconian science contribution to knowledge consisted mainly in opening up new fields of investigation, often by borrowing from arts and crafts. Its practitioners were mainly amateurs, often guided by utilitarian purposes, and it was not until the end of the 18th century that some of the knowledge produced in this manner became organized and systematic. By contrast, classical science was paradigmatic, articulated, and formalized. When experimental, it performed experiments as tests of previously articulated theories. According to Kuhn, Newton was the only practitioner of the 17th century who practiced both types of such sciences. But Newton's notable achievements were in the classical paradigm and not in the newly formed or new Baconian science. Newton's Baconian investigations in the field of optics and alchemy merely opened up questions for the generations to come. This separation between a Baconian science and the other, classical science or Newtonian science, was repeatedly criticized in the past decades. And historians and philosophers have changed substantially the way we talk about Baconianism and Newtonianism, even if some traces of the simplified contrasting image are still lingering. In recent years, an increased attention to actors' categories and an augmented sensitivity to the context have unveiled a rich spectrum of Newtonianisms and Baconianist characteristics for each epoch. My purpose in this talk is to discuss and classify these terms and to show how they got to be used as historiographic categories in the past 300 years. So I'm talking about labels here, Baconianism and Newtonianism. And I'm saying that labels can be used in two ways. The first is in self-attributive manner. When one identifies oneself as a Newtonian or a Baconian, this means he's a follower or a disciple. But what kind of disciple can vary, and at various times, being a Newtonian or being a Baconian is correlated with a particular conceptual, sometimes even textual reconstruction, and with different historiographic presuppositions. 18th century Newtonians, for example, as we shall see, worked with the corpus of text centered on the Principia without much knowledge of Newton's alchemical pursuits, for example. As we shall see in what follows, many 17th century Baconians work with the assumption that Bacon's main contribution to the advancement of knowledge is his map of the sciences and his natural histories, and with no major reference to the Novum Organum. By contrast, 19th century Baconians took Bacon or the Baconian science to be explained in the Novum Organum and regarded the natural histories as appendices of a secondary importance. So self-attributive labels comes together with the context, and the same label, Baconianism, can be very different according to that context. Now, there is another using of labels. We can say about someone that is a Baconian or a Newtonian in a polemical manner. And this is how, for example, as we shall see in various histories of philosophies, Newtonianism was constructed in opposition with the Cartesianism, or in the 19th century, in opposition with Baconianism. And there is another way in which you can talk about these terms, and that's the historiographic label. Now, both Baconianism and Newtonianism were used as historiographic categories ways before Kuhn. And the question is how they were used, and I'm going to try to show here that in most of the cases, what happened was that a self-attributive label was turned into a historiographic category, or a polemical label was turned into a historiographic category. But the kinds of histories that result are different, because if we turn a self-attributive label into a historiographic category, what we get is an apologetic history of a certain discipline, while if we do it the other way around, if you turn a polemical historiographic category, a polemical label into a historiographic category, you can get a different thing. You can, for example, get a kind of the revisionist history. Okay, so what I want to do is to just show you several ways in which self-attributive and polemical labels were turned into historiographic categories in the past 300 years, just by way of example. And just to show that Kuhn was not the first to reconstruct the history and philosophy of science out of polemical labels turned into historiographic categories. And more generally, I would like to address a more philosophical question about what kind of distortions we are introducing in our histories if we do this, namely turning labels into historiographic categories. So, as a first example, the Baconian science in the 17th century, the second part of the 17th century. 17th century talked a lot about Baconian science or Baconian sciences. And what naturalists meant by this is not the caricature that Kuhn paints in his paper. First of all, it was not fact gathering, and it was not mere natural history. Baconian science was a large project with a complex architectonic, with ways of producing knowledge and good practices and bad practices to be avoided. A big project on a large scale, collaborative, projective, and dynamic. And it started from a particular way of looking at Bacon, by looking at Bacon as the architect of a map containing arts and sciences and an architect of arts and sciences itself. As we can see on the frontispiece of Thomas Pratt's History of the Royal Society, 1667, where Francis Bacon, here on the right, bears an inscription under his feet artium instaurator, the initiator, the instaurator, the initiator of arts and sciences. And this is how many fellows of the Royal Society treated Bacon, and this is how they related to Bacon's project, and this is how they consider themselves to be Baconians, as continuing a project that Bacon initiated of founding and developing new sciences. To be a good Baconian in this particular self-attributive way was to come up with at least a new science constructed on Bacon's plan and looking up into Bacon's works for models and examples. And although to our eyes this looks a bit strange, 17th century virtuosi had ample textual evidences for reading Bacon's precisely in this manner. Such was the English edition of an edition of Bacon published in 1640 by Gilbert Watts under this double title. You have here both the Instauratio Magna, the title of Bacon's Magnus Opus, never written, so the Great Instauration, and you have the title of the Advancement and Proficient of Learning, or the Partition of Sciences in 9 books, which is the title of one of Bacon's works, a work published in 1623 in Latin. So what Gilbert Watts does here is to, in a way, start from the project of the Instauratio Magna, a volume published by Bacon in 1620, which contained, among other things, the Novum Organum. But instead of publishing the Novum Organum, Watts publishes the first part of what was supposed to be the Instauratio Magna, namely the Partition of the Sciences, the map, Bacon's map of arts and sciences. And this is very interestingly signaled in the title pages of the two works. So Gilbert's title page, it's kind of a very interesting gloss on the Bacon's initial title page, keeping the columns of Hercules and the ship that goes beyond the columns of Hercules, but adding to it interesting iconographic elements to show that we are facing something else than the 1620 book. We are facing something interpreted by Gilbert Watts. That's the complete title, and Gilbert Watts claims that he has interpreted Bacon for us. And in the epistle dedicatory to Prince Charles, future Charles II, Watts states that this is the author I here present to your highness. This is his work, which by the powerful influence of your favor shall prosper, and it may be quickened to the regeneration of another phoenix out of his ashes to adorn your world. For it is only the beginning, the benign aspect and irradiation of princes that inspires the globe of learning and makes arts and sciences grow up and flourish. Clearly, Watts' translation has its own agenda, and depicting Bacon as an artium instaurator is a part of it. And this is done in a countless way throughout the volume, as for example, fleshing out the words an instauration of arts and sciences in the text when they appear. We see them here on the left. Or by introducing the plan of the work with the words an architecture of the sciences. Here is architectura scientiarum, something that is not in Bacon, something that Gilbert Watts adds to show that what he wants to do in this volume is to present a systematic Bacon, but not a Bacon that begins with the method and the Novum Organum. A Bacon that begins with the plan of a general map of sciences on which we should introduce new arts and sciences according to Bacon's own suggestions, a plan to be continued by the 17th century Baconians. Gilbert Watts was not alone in feeling the need to systematize Bacon's corpus. The first 18th century editor of Bacon's works, Peter Shaw, was sometimes characterized as a minor Newtonian. Shaw was a successful physician, a practicing chemist, and a prolific writer of his own. He translated, edited, and methodized the works of Francis Bacon and the works of Robert Boyle. And like Gilbert Watts in the previous century or previous generation, Shaw presented Bacon as an art instaurator, as a creator of sciences. Moreover, he claimed that all 17th century natural philosophers, including Newton himself, worked along Bacon's line or on Bacon's plan. And Shaw's edition of Bacon's works, methodized, set to demonstrate precisely that, namely, I quote, how far the several plans of the author for the advancement of all parts of knowledge have been executed to the present time. Peter Shaw clearly did not see Kuhn's divide between Newtonian and Baconian science. To him, science was one and was invented by Bacon and continued by Boyle and Newton. Not only in this edition of Bacon, but in his own work on chemistry, Shaw attempted to place Bacon at the origins of all discoveries and inventions, and he saw most of the new sciences as deriving methodologically from Bacon's precepts and from his art of experimenting. Again, not from the Novum Organum, but from the Experientia Literata, from Bacon's methodology of experimentation. According to Shaw, the design of this first part of the instauration is to give a summary account of that stock of knowledge whereof mankind are possessed, to lay this knowledge down under such natural branches or scientific divisions as may most commodiously admit of its further improvement, to point out deficiencies or desiderata, and lastly to show by examples the direct ways of supplying these deficiencies. So Shaw reconstructs a Bacon centered again on the map of knowledge and sees the general project of the Baconian science as an attempt to build more and more sciences into this map according to the method of natural historical research and the learned experience. And Shaw clearly sees 17th century science as developing along the line of these, quote, designs, bringing them to fruition, or in short terms, I quote, to their full latitude, scope, and tendency. Okay, what we see in these editorial attempts is how a self-attributive category of Baconianism gradually becomes a historiographic category. Watts and Shaw supplement plan with what is Bacon's plan with what is missing. They make difficult decisions. They interpret Bacon's text in a particular manner. In a way, they are providing us with both an edition and a philosophical interpretation of Bacon's works, and then they turn that Baconian science category into something into their centerpiece for actually recreating a history of science, for discussing the whole 17th century or even before, in Watts' case, to discuss the 16th and 17th century, to discuss the novatores, the new philosophies, with the help of this Baconian science, with the help of this historiographic category. Okay, what does it mean to create a new science? Now here I'm just giving you a very, very brief example that Bacon had in mind, that we need to create new sciences, and he's giving some examples of how to do that. And one nice example is his pair of two sciences. One, a physical astronomy, he calls it astronomia sana, and the other paired with its natural philosophical counterpart, a new astrology. So the Astronomia Viva and the Astrologia Sana is the name of the two sciences that Bacon wants to construct, and he's giving in the Augmentus Scientiarum instructions on how to do that. How do you construct a physical astronomy starting from a natural history of the heavens? How do you construct a new astrology that is that it's reformed? That's a bit more complex, but he has some ideas there too. What is interesting is that in the second part of the 17th century in England, There's a project to do this, to do precisely what Bacon claims there that we should do. Joshua Childrey, naturalist and committed Baconian, worked for a long time to complete this precise design. He set to compile a general natural history of the heavens on which to build a new, properly constructed science of astrology. Like Bacon, he never managed to finish this project. Only a few bits and pieces have survived. We do have a sort of preface manifesto of the project, the Indago Astrologica of 1652, and we have also a manuscript now in the British Library entitled Urogon Cometorum, a dissertation partly mathematical, partly physical, touching the new comet which appeared in the constellation of the Orion. And in the British Library manuscript ends with an advertisement for astronomers and astrologers, which Child retraces, the future contours of a science of comets, describing the kind of investigations, instruments, and questions that future astronomers have to set into motion in order to be able to develop this new science. Joshua Childrey is thorough Baconian in his methodology. He conceives the project of reforming astrology as collaboration, and he enlists the help of two astrologers, John Gould and John Gadbury, to construct this new project, this new Baconian science. Now, in his very short presentation of these two new sciences, the astronomy and the astrology, Bacon proved to be most interested in astrometeorology. That was his astrology. And this is also precisely what Childrey and Gould are working on. They both kept extensive weather diaries, recording temperature, humidity, precipitations, wind, and noting down carefully the planetary aspects at all these times. Some of these results were eventually published by Gould in 1686 under this title, and Gould also published in 1690s the same thing under a title that looks much more Newtonian, the Astrometeorologia Sana, or the Physico-Mathematical Principles, a title which also shows no awareness of any divide with the Newtonians. Now, neither were the Newtonians aware of a divide, or at least not all of them. Peter Shaw, whom we encountered earlier, adds to his translation of the De Augmentis Scientiarum copious footnotes, in which he points out which of the points in Bacon's plans were realized. And the footnotes to this Astronomia Viva are particularly telling. So he says the author made an attempt to supply this desideratum, namely a science of living astronomy. His design was to rescue from the science from the usurpation of mathematics, so to make a physical astronomy, not merely mathematical astronomy, and render it more extensive, philosophical, and serviceable. But he does not appear to have had many followers in this way, few besides mathematicians thinking themselves qualified to do astronomy. And then astronomical mathematicians seldom cultivated more than mathematical or systematic part, as Galileo, Kepler, Watt, Hevelius, except Newton, except Sir Isaac Newton, and upon his foundations, Dr. Gregory, Cale, Winston, etc., have introduced more natural philosophy into astronomy. However, the physical part of the science has not hitherto been sedulously cultivated and kept clear of systems and hypotheses according to the direction example of Lord Bacon. Interesting are also Shaw's remarks regarding Astrologia Sana, which he thinks can be and should be developed in the future on the basis of Newton's discoveries and some foundations set by the observations of Hevelius and Flamsteed. Okay, but how are these new sciences actually produced? So where is the Baconian method here? And the general answer of these people at the end of the 17th century, the beginning of 18th century, seems to actually follow not the Novum Organum again, but Bacon's plan in the Augmentis Scientiarum for the multiplication of the sciences. Bacon observes there that it is the duty and the peculiar virtue of all sciences to abridge the roundabout and long circuits of experiments. And this is excellently performed by collecting and uniting the axioms of sciences into more general heads and conceptions, which may be agreeable to all individuals. For sciences are the pyramids supported by history and experience as their only true basis, and so the basis of natural philosophy is natural history. The stage next to the basis is physics. The stage next, the vertical point, is metaphysics. And as for the cone and vertical point is the summary law of nature. These are the true stages of the sciences. This quote can be a bit confusing because it contains reference to a general method and it contains an example. The general method we have to infer is the one of the Novum Organum. Scientific knowledge proceeds from observation and experiments. This in Bacon's terms are called history and experience. Through observations and experiments, particular experiments, what in the Novum Organum are called prerogative instances. And through this, along this road, the science aims at producing axioms. For Bacon, axioms are theoretical causal statements of different degrees of generality. Axioms once produced are tested through other experiments, and each established axiom generates somehow its own experimental program. And Bacon insists very much in the Novum Organum how mistakes can happen in this road, and how we should avoid these mistakes, which he calls anticipations of nature, and how it's extremely difficult, almost impossible, to avoid anticipations, namely undue speculative steps or hasty speculative steps. But the methodological requirements that Bacon sets in the Augmentis Gentiarum and then in the Novum Organum are quite simple. Proceed from experiments, try to produce axioms, do not produce anticipations, advance with cautious steps, test your axioms, and try to deduce from them consequences and see how fruitful they are. And most importantly, do this for each science, for each field of knowledge. For the old ones, because they are in need of reconstruction, but also for new ones, for the empty spots on the map of knowledge, such as the Astrologia Sana or the living astronomy. And the model of this progressive way of obtaining successive generalizations for particular sciences is very well illustrated in the Augmentis Gentiarum in the way in which Bacon suggests that mixed mathematics will develop in the future. He says mixed mathematics has for subject axioms and portions of physics, and considers quantities as it is auxiliary to enlighten, demonstrate, and actuate these axioms. For many parts of nature can never be sufficiently subtly comprehended, nor demonstrated with sufficient perspicuity, nor accommodated to use with sufficient dexterity and certainty without the aid and the intervening of the mathematics. Of which sort, examples of the sciences are perspective, music, astronomy, cosmography, architecture, engineering, and diverse others. But in mixed mathematics, he said, I cannot report entire portion deficient. I rather make this prediction that there will be more kinds of them. There will be more mathematics in the future, invented by posterity, if men be not wanting to themselves. So if we are not lazy, we are going to produce more mixed mathematics. For as physical knowledge daily grows up, so new axioms are produced in natural philosophy, and new axioms of nature are disclosed, there will be a necessity of new mathematical inventions, and so at last, more mixed mathematics will be contrived. It is clear from this quote that Bacon saw the establishment of axioms with a higher degree of generality as foundational for new fields. One discovers new axioms and then mathematizes them, and establishes a new mathematical science such as the physical astronomy or the Astrologia Sana, the same astrology. Okay, now what happens with this in the field of the Newtonians of the 17th century? We have already seen a minor Newtonian enlisting Newton among Bacon's followers. And it's not, if you look at Bacon from this angle, if you look at Bacon as the precursor of a proliferation of mixed mathematics, then it's not surprising somehow. But let's have a look at two hardcore Newtonians upon whose works was built much of the 18th century Newtonianism, Henry Pemberton and Colin Maclaurin. Now, Henry Pemberton, trained as a doctor, moved to London. He became Newton's follower and disciple, and he was in charge with supervising the third edition of the Principia. And he published this widely read account of Sir Isaac Newton's philosophy, in which he simply inserted Newton in a Baconian tradition. Using the self-attributive use of labels, Pemberton makes Newtonian science a natural development of Bacon's science. Bacon, he claims, described the true method which ought to be followed, and this true method was one of gradual generalizations, quote, to proceed cautiously, to advance step by step, reserving the most general principles for the last results of our inquiries. Pemberton sees the distinction between the anticipations of nature and interpretations of nature as crucial for this method, and give ample treatment of various anticipations and their causes. He discusses Bacon's theory of the idols, the main causes of anticipations, only changing Bacon's example. So he's just really going along the Novum Organum, discussions of the idols, changing Bacon's examples with his own favorite examples, Descartes and Spinoza and the speculative philosophers. Pemberton contrasts all the time Newton with Descartes, showing how much Newton followed Bacon and how much he acted according to Bacon's plan. The principle of his philosophy are, upon no consideration to indulge conjectures concerning the powers and laws of nature, but to make it our endeavor with all diligence to search out the real and true laws by which the constitution of things is regulated. The philosopher's first care must be to distinguish what he sees to be within his power from what is beyond his reach, to assume no greater degree of knowledge than what he finds himself possessed of, but to advance by slow and cautious steps, to search gradually into natural causes, to secure himself the knowledge of the most immediate cause of each appearance before he extends his view farther to causes more remote. This is the method in which philosophy ought to be cultivated, which does not pretend so great things as the more airy speculations, but will perform abundantly more. We shall not perhaps seem to be the unskillful, to seem to the unskillful to know so much, but our real knowledge will be great. Now, a full treatment of all this is beyond the purpose here, but this is just by way of example. And I would like to have a very brief look at another Newtonian, Colin Maclaurin, who worked a lot at this book, an account of Sir Isaac Newton's philosophical discoveries, published posthumously in London in 1748. What is remarkable in this book is the attempt that Colin Maclaurin does to integrate Newton in a full-length history of philosophy as a sort of culminating point in the development of human thought. So it's an apologetic history of philosophy. And in order to do this, Maclaurin uses both self-attributive labels, such as Baconianism, and polemical labels, such as Cartesianism or Cartesian, as historiographic categories in his history of philosophy, as lenses through which one can see and interpret the whole history of natural philosophy, or more precisely, the history of what he calls experimental philosophy. Newton, claims Maclaurin, quote, "This philosophy, experimental philosophy, intimating by the name the essential difference there is betwixt it and those systems that are the product of genius and invention only." And the founder of this experimental philosophy for Maclaurin was Francis Bacon. Here is the quote. He is the founder of experimental philosophy. When he rejected the Aristotelian philosophy, the whole history of how Bacon became the founder of experimental philosophy. He proposed his plan, etc., etc. I'm not going to read this. Maclaurin gives a brief description of Bacon's vision of science and method of inquiry, paraphrasing or simply copying the relevant paragraphs of Francis Bacon's De Augmentis Scientiarum. Here is one. He considers natural philosophy as a vast pyramid that ought to have history of nature for its basis, an account of the powers and principles that operate in nature, which he calls the physical part for the second stage, and the metaphysical part as the third stage. And it's basically a kind of gloss, almost a copy of the paragraph I showed you before, so I'm not going to read it again. It's kind of lifted from the Augmentis Scientiarum and placed in Colin Maclaurin. Maclaurin also quotes from the Novum Organum, whose book 1 is something he seemed to have fully digested. Here is a quote: "The empirical philosophers, those who have no higher view than to collect the history of nature, he compares to the ants who gather the grain and lay up as they find it, the sophists to the spiders who form their webs from their own bowels to catch unwary insects in their aerial flights, while the bee that gathers the matter from the flowers of the field, from which with admirable skill she makes her honey, is the emblem of the true philosopher, who neither trusts wholly to his own understanding, not contents himself with recording the matter with which he is furnished from natural history of mechanical experiments, but by reasoning skillfully from them, brings forth truth and science, the great and noble production of the human faculties." The skillful reasoning is the good induction, quote, or the kind of logic as might be of real use in physics. It is the kind of logic that Bacon's followers simply failed to apply and understand, with the exception of Newton himself. And the reason for the failures of the others, claims Maclaurin, lies not so much with Bacon's plan, but with the advent of the opposition, the speculative philosophy of Descartes and Spinoza. Due to the spreading of this speculative philosophy, Newton's method, which is just an application of Bacon's method, was not fully appreciated and not fully understood by his contemporary, claims Maclaurin. While all admire the sublime geometry which shone throughout his work, few for some time appear to be disposed to hearken to his philosophy or in a condition to judge it impartially. So Newton met with opposition in this story that Colin Maclaurin puts together. And those who admire Newton the mathematician did not fully understand the unity of his thought. And the unity is given by the Baconian method, a method that Maclaurin claims was equal in mathematics as in natural philosophy. And in order to argue for this claim, Maclaurin reconstructs first a very Baconian approach to mixed mathematics, taking mathematics in general to be a tool, like Bacon did. He claims, in fact, that we have proof of the advancement of learning in the mutual collaboration between philosophy and geometry, or more precisely in the fact that more and more axioms and principles receive a mathematical quantitative expression. Here is a quote that I'm not going to read. And second, in order to illustrate the growth of knowledge through the collaboration of physics and geometry, Maclaurin uses the self-attributive label of Baconianism, which we have seen is a reconstruction, as a historiographic category, this time in order to rewrite the history of mathematics. He claims that mathematics itself was a Baconian science, the result of experimental investigations constructed bottom-up from phenomena, observations, and measurements. He begins with the ancient mathematics and claims that it was a science of measurement involving empirical quantities, and he claims that it has developed subsequently, driven by attempts to produce better measurements and clearer practice-based definitions and discoveries in a gradual ascent according to the familiar pattern of Baconian science. This Maclaurin emphasized in stark contrast with the ways natural philosophy was pursued since Bacon by Descartes and Spinoza and their followers, the speculative philosophers who proceeded by anticipations, speculations, imaginary superstructures, each system more fantastic and idolatrous than the previous one. So what did we see here in this section of my talk? Two major Newtonian figures of the 18th century using the self-attributive label of Baconian science for their enterprise. And in the case of Colin Maclaurin, we can see how he explicitly used the same label to create from it a historiographic category in his reconstruction of a philosophically informed history of mathematics, as well as a more general Newtonian history of philosophy. Now, I'm going just to briefly say that I don't have time to develop this, but somehow the unity between Baconianism and Newtonianism broke only in the 19th century. And what happened in the 19th century was that first, an interest in Newton's papers sparked an interest in Newton's biography, which in turn sparked debates about the unity of Newton's project and questions on how to integrate the various different aspects of his research and personality. And of course, the problem of Newton character emerged. And then there were several forms of Newtonianisms that find themselves in kind of competition in the 19th century. Those who reconstructed Newton solely as a mechanical, in terms of classical mechanics, in a way lost the battle, and another Newton came up. And a very interesting character in this story is Francis Bailey, adventurer and explorer, accountant and clerk, successful banker, astronomer, and historian of astronomy. Because Bailey saw himself engaged in a particular discipline, the practical astronomy. That's precisely what Bacon would have called a natural history of the heavens. Practical astronomy involved not only making accurate astronomical observations, but also recovering from ancient documents past observations and keeping track of historical records of past astronomers. Now, as Rebecca Higgett nicely shows, Bailey seems to be a typical case of a new convert who gradually came to believe that he had to save and reconstruct the whole field of knowledge. And he saw himself as engaged in saving data from old records and defending the reputation of past astronomers. And this is the man who found Flamsteed's paper at the Greenwich Observatory and became the champion of Flamsteed's reputation. He saw in Flamsteed a kindred spirit, and he saw that Halley and Newton have wronged Flamsteed. And Francis Bailey's account of the Reverend John Flamsteed, 1835, created a sort of havoc amongst Newtonians and changed the direction of Newtonianism in the 19th century. And created a lot of interesting discussions in which both Newtonians and Baconians entered, among which one of the most important and interesting character was William Whewell, who wrote a Newton and Flamsteed in 1836, and then started writing his own project of rebuilding some sort of Baconianism that would integrate Newton in it, which was the last step of an attempt to do that. And it was, of course, very important for turning labels into historiographic categories. But I'm not going to go into the details, just to summarize. So in parallel with what happened with the breakup of the Newtonian consensus, 19th century England saw a breakup over the Baconian consensus, which took place exactly like the first one, even if Bacon never left an archive, on debates of how to reconstruct the Bacon's edition, which did not center anymore on the Augmentis Scientiarum and the map of the sciences, but which centered on the Novum Organum. And Whewell was instrumental in the production of the Victorian edition of Francis Bacon, realized by Spedding and his colleagues from Trinity College, an edition that basically creates the Bacon of the 20th century. It's the Bacon of the author of only one book, the author of the Novum Organum, and everything else is kind of appendices to the Novum Organum, and also the edition of Bacon, almost like in parallel with the work on Newton, raises the problem of Bacon the man, the problem of the very bad character of Bacon and his problems in political problems, ethical problems, philosophical problems. So the Victorian Baconians and Newtonians, this is what I'm trying to summarize here, because I'm very late and I know I have overstepped your patience. The Victorian Baconians and Newtonians had very different Bacons and Newtons to defend. And they were Baconians and Newtonians with very different agenda. What Baconianism meant for Whewell was very different than what Baconianism meant for Shaw. Okay, now what about Kuhn's Baconian science? Do we learn anything from all this if we go back now to Kuhn's labels? I think we do, because what Bacon used in the what Kuhn's uses in the fabrication of this historiographic category is something similar. So in order to defend his philosophical theory of the scientific revolutions, Kuhn needs to find in the history of human thought something like his own conception of normal science. And following Koyré, Kuhn takes astronomy as his best example of normal science that undergoes a crisis followed by a revolution. He takes this story, the story was already there, it was said. And if we think nowadays, we don't really believe that there is such thing in astronomy as a normal science. He works with a clearly 19th century reconstruction of what the history of astronomy was, a Newtonian reconstruction of the history of astronomy, as well as a 19th century Newtonian reconstruction of mathematics and the history of mathematics. As we have seen, 18th century Newtonians had a very different concept of what ancient mathematics was and what ancient astronomy was, more in line with the Baconian natural history of the heavens and with the empirical practice-based experimental research, and more aware of the fact that astronomical inquiry is a very much an evolving exploratory field and not a discipline in its own right. But for the Kuhn theory of the revolutions to be instantiated, one needs to overlook the disciplinary differences between the traditional mixed mathematical science of astronomy and the celestial physics of Kepler, for example, and to see both as species of the same mature form of paradigmatic investigation. The category of Baconian science is constructed in opposition with this, as a pre-paradigmatic form of knowledge, open-ended and exploratory, a common field from which disciplines are slowly emerging. And I think that Kuhn needed this common repository of empirical knowledge to explain his own account of the 18th century chemical revolution. And therefore, what we have again in Kuhn's attempt to build up historiographic categories is again a polemical label turned historiographic, as in the story I have been telling you so far about the 17th and 18th and 19th centuries Baconianism and Newtonianism. Thank you. And sorry for rushing. I'm already very late.
Thanks so much to Professor Jalobeanu, and everyone joins me in thanking them. Thanks so much. And that said, let's move into Q&A. If there are questions, comments, rejoinders, objections, perhaps, don't hesitate. Could I perhaps break the ice, as I shouldn't, by raising a very specific and perhaps detailed question? At some point, I believe you mentioned Maclaurin, and you talked about his views. And there was a quote there that you projected. And if I remember correctly, Maclaurin, as a Newtonian, notwithstanding, talked about weight as a property that features in geometry. And that seems to be a very Cartesian thing to say. And so naturally, I wonder if there was a mix of traditions at the time, or if Maclaurin is best construed as a figure that seeks to integrate these issues. Thanks.
This is a Renaissance topos, that weight is a property of geometry. Actually, you find it in the 16th century Paris attempts to redefine various mixed mathematical sciences. It's very standard. Now, if anything, Descartes eliminates it because he doesn't have a notion of weight. or at least not a primary notion of weight. So he cannot use it as such. But everyone else in mixed mathematical sciences, including Bacon, uses it, and the Royal Society, for the Royal Society, that's a very important thing to have. They are just talking about the traditional way of constructing mixed mathematical sciences.
And so if we just think of, oh, sorry, go ahead.
No, I mean, just what is new in it. And it's not even new because he's basically picking up a Renaissance tradition, which claims that geometry is a science of measuring. That's even something that people would find in Ramist textbooks of geometry. So it's not new. It's kind of not that fashionable in the beginning of the 18th century, but Maclaurin is reviving it and putting it together with this Baconianism to create a history of mathematics, very traditional Renaissance history of mathematics that leads up to Newton.
So is the thought to infer mass by considering the law of attraction and considering what the gravitational attraction might be and what the gravitational force might be, and then considering the relative forces of the two bodies? Or how exactly is weight supposed to be a geometrical property for an 18th century Newtonian?
Oh, weight is what you measure with the balance, or what the Torricellian tube liquid weights, or the pressure of the air weights upon the mercury. That's what the weight is. Doesn't have anything to do with the mass. And this is the general notion that all mixed mathematicians are kind of using, and they are interested in how weight increases and decreases with height. So Royal Society does experiments carrying Torricellian tubes on hills around London, as well as, the French famous experiments on Puy de Dôme, carrying tubes up on the mountains in Provence. And they go down in mines with all sorts of things. Hooke has an experiment that takes place on the spire of St. Paul before the fire of London, the old St. Paul, all attempting to measure the variation of weight with height, and therefore, in a way, the force of attraction. That's before Newton, okay? So this is the mathematical tradition that Colin Maclaurin talks about. In this sense, weight is part of mechanics, and mechanics is part of mixed mathematics.
That's great. Thanks so much for clarifying. And if there are further questions, comments, rejoinders, Theo, please go ahead.
Thank you very much, Dana. I mean, that was really interesting. I have a question about, the historicization of labels. Okay, so when labels appear, they appear, as you said, in a self-attributive. They have a self-attributive character. Then they may turn into polemical. They acquire a polemical character, and then they get incorporated into historiography. And I was wondering about this last final stage. Given that the same label has been used in very different ways, then can we conclude from that it has lost its historiographical utility? Because it doesn't have any definite content, and as historians, we want to, of course, we want to respect actors' categories, but given that actors' categories are very fluid and at different times they have very, very different content, then we should be extremely cautious, I think, to use the same labels.
I mean, that's the one problem. There are a number of problems with labels, and as you pointed out several of them, let me point out some more of them. So One problem with the labels is that we tend to conflate historiographic and historical categories. And we also tend to conflate our historiographic categories with their historiographic categories, which is the most common kind of conflation. So my kind of general point is that we should be very careful when we read to look for historiographic categories that were already built into the 18th century histories of philosophy or the 16th century history of philosophy. So it's not that we add a layer on the actors category terms. We add two layers. They themselves have added a historiographic layer, and we add a second row of historiographic labels on the top. So therefore, it would be much better to refrain from using Cartesianism and Baconianism with any kind of sense we have today on the top of all this very complex structure of Cartesianism and Baconianism, or any other layer that they had at that time. And maybe we should come up with new historiographic labels. That's my point. Or at least if we use it, then be aware of the layered structure of labels that is beyond our feet.
That's what I was getting at, and I wanted to make sure that I understood your point, that you are recommending in a way to not to use those very historically laden categories and come up with perhaps more neutral categories, or I don't know what would be the solution.
I'm not quite sure what we can come up with, but yes, something like that. It would be very good.
Great, thanks so much to both. Other comments, questions, rejoinders, don't hesitate.
There can be no neutral category, historiographical category. Each category will have its own defects. So ipso facto, each category, just by sectioning a slide of the whole, will be open to objections. This is history, it's not an exact science. Each concept.
Yes, I agree with that, but think that, okay, so if you look at these examples and you compare between them, the history of philosophy that was done with, let's say, Colin McLaurin's history of philosophy, even with Pemberton's history of philosophy, which is strongly anti-Cartesian and very polemical, you see that Colin McLaurin, although not, I mean, also taking a stand and trying to build up an apologetic history of philosophy, is more careful, and the result is a more nuanced and more rich history of philosophy than the simplistic history of philosophy that you can do with a very strongly polemical. So one thing that I have learned from this very intricate history, historical research that I did, was that as a sort of general rule, although it's not necessarily obvious, but in these particular cases, turning self-attributive labels into historiographic category results in richer reconstructions than the polemical version, okay? So it's not that it doesn't matter, no matter how we choose, we are always biased. Of course we are, but in some cases you can be a more
There are different levels of biases.
Different levels, yeah, exactly. So we won't ever reach a neutral point of view, but we might reach a less biased point of view.
What a wonderful joint conclusion. And I wonder, thanks so much to Dr. Grigorievida, and I wonder if there's some more comments, rejoinders, questions. And if not, please join me once again in thanking Professor Dana Jalobeanu for a wonderful talk. Thank you, Dana.